I can't imagine a better person to wrap this all up for us. This is going to be a great talk. All
Thank
right,
you.
Enjoy.
Thank you very much. So, hi everyone. This is Micrometer Mastery, and this is kind of like our an advanced observability talk. I did another talk on Monday, I guess. That was like covering the basics. If you haven't seen that, don't worry. I will cover or recap that for you. So I am part of the Spring engineering team. I usually work on Micrometer and sometimes rarely on Spring Cloud and Spring Boot as well. And I am part of the Spring Observability team with two of my colleagues, Marcin and Tommy. And we are basically working on observability features across the Spring portfolio. I am also one of the leaders of the Seattle Java user group, and you can find me online. I have the blog and my social handle there. So let's do the recap about the basics. First, let's define what is observability for this talk. And it is really how well we can understand the internals of a system based on the outputs that it will provide. But this is just a fancy way of saying observability is data about your application. What data? Any data that can give you some value. Why do we need it? In one word, because of complexity. Because today's systems are very, very complex, increasingly and insanely complex and complicated. And if you need to troubleshoot something here in these environments, that's not easy. Also, they are not just, because they are huge, because of the law of big numbers, something is always broken. And they are very chaotic as well, which means that you do some modification somewhere, a little modification, and somewhere else applications will go down. Also, we need to deal with unknown. You cannot know everything. There are things in your infrastructure right now that you don't know about. You don't know that they even exist and they can bring down production. And also, to make this a little bit worse, things can be perceived differently by different observers, which means that maybe 100% fine for you, but at the very same time, everything is broken for your users. But also, let's answer the question, why do we need observability from the business perspective? And I guess in one word, because of money. Because we can reduce loss of revenue from production incidents just by, if you are able to troubleshoot something faster, you might be able to fix it faster. And also, it might require less specialized knowledge. So everyone can troubleshoot things. You don't need a tribal knowledge or a separate tool for every single application that you have. And you can also quantify user experience, which means that you can measure things. You can measure how your users are experiencing your production environment right now. And you don't need to guess about it. That's a great thing. So let's talk about logging metrics and distributed tracing. These are the huge or three big signals of observability that are the most people are familiar with. So let's say what you can do if you want to implement these with Spring, or the JVM as well. So if you want to do logging, we usually recommend using SLF4J with logback. SLF4J stands for Simple Logging Facade for Java. And this is a simple API. You can just do your log statements and emit your log events, and then you can plug logging libraries in and out. And it is that simple. Spring Boot comes with SLF4J plus logback auto-configured for you. So that's a great thing. Logback is a native implementation of SLF4J, but you don't need to use that. If you want to use log4j too, you just need to replace a dependency with boot, and boot supports that as well. And that's it. If you want metrics, we usually recommend using Micrometer. And Micrometer is a dimensional metrics library for the JVM. And it is kind of like the SLF4J situation, because Micrometer has a nice API which is independent of the configured metrics backend or backends, because you can use multiple backends with Micrometer. You don't need to use one, but that's usually what people do. We have support for many backends. I believe 20-ish, 20 plus. And Spring Boot actuator will bring in Micrometer for you, and it will auto-configure that for you as well. So that's a great thing. You will get it out of the box. Also, there are the Spring portfolio, the Spring projects. They are instrumented using Micrometer. And there are many third-party libraries that are instrumenting themselves with Micrometer. That list, by the way, is shockingly long. If you want to implement distributed tracing, then there is a difference between if you are using Spring Boot 2. How many of you are using Spring Boot 2? 1, 2, a couple. Okay. So if you are using Spring Boot 2, we recommend using Spring Cloud Sleuth, which is the distributed tracing support for Spring Boot 2 based projects. But if you are using Spring Boot 3, or you are not even using Spring Boot, but any JVM application, then we recommend using Micrometer Tracing. And Micrometer Tracing is a tracing library, or a tracing facade, just like SLF4J, which was created from the code base of Sleuth. So if you are familiar with the API of Sleuth, the Micrometer Tracing API is basically the same. We just renamed the package and fixed something. But basically, Micrometer Tracing is a copy of Sleuth under the Micrometer umbrella without the Spring dependencies. So you can use it in any projects under the JVM, which is pretty nice. So both of them, they are providing an abstraction layer on top of tracing libraries. Again, this is the SLF4J situation. You can plug these tracing libraries in and out as you want. We support two of them right now. One of them is called Brave from the OpenZipkin community. And this is kind of like the default, but there is no default because you need to choose. The other one is called OpenTelemetry. It's a CNCF project. And this is kind of like the experimental one because OpenTelemetry is not 100% stable yet. Also, we have instrumentation for Spring projects. Third-party libraries are using these as well to instrument themselves. You can instrument your own application. And they support like Micrometer Tracing and Sleuth, they both support various backends, like tracing backends, because the tracing libraries that they are using under the hood are supporting many, many backends. So let me give you a very quick demo about how can this look like in action. The demo is open source. It's on GitHub. You can go to the URL or like follow the QR code. And this is kind of like our architecture. The users can call the application called T-Service. T-Service will call T-Leaf service and voter services over HTTP, and they have their own databases. It's quite simple. So let's see that application in action. And you probably can tell that I am not a front-end engineer by this UI. But since last year, we demoed the same application last year. We worked a lot with two of my colleagues to just improve this UI. And you can see that improvement above. It's the Spring logo. It was a lot of work. So what you can do here, you can you can choose the T type, and you can also choose the amount of water. Press the button, you will get like a recipe, and that's it. You can choose like any of these, and we have a problem. Internal server error. That's not good. That's not a good flavored tea, I guess. So let's look into a couple of things. One, what happened? Well, internal server error, but behind that, what is the context of this? Is everything broken right now? Is it only broken for me? Or like, is it a one-off? What is going on? And lastly, let's also check like why this is happening. So let's start with the context, because I happen to have some dashboards here. What you can see here is up there is the success rate, down there is the error rate. The error rate is, well, it's ironically green, Grafana. But what you can see here that this wasn't a one-off. This is kind of like a steady stream of errors. Like the error rate is around 0.5 like errors per second, and the success rate is 4.5 around that. So we have like 10% of the error rate. So let's try to figure out like what happened and why. And while I will like walk you through that, let me also demo a few concepts. And first, let's see how can you jump between these signals. Like how can you jump, for example, from logs to traces? So if I go to the logs, I should have some logs in Loki here. And let's say I am searching for log level equals error. You can see that there was like an error here. It was a 404. So this is kind of like what happened. Why this is happening? I have no idea. But we can jump from this log event to the distributed tracing backend to this very event by a thing called log correlation. If you look into here, if Grafana will not like block the screen, then what you can see here is the trace ID and the span ID. In distributed tracing, a span is basically an event that you want to observe, And these spans are basically connected with like causal relationship. They have this parent-child relationship. One span was triggering another one and so on. And all of these spans that are grouped together, that is called a trace. Every span has an ID and every trace has an ID. And this log message contains the trace ID and the span ID here. So that means I can just copy this ID. I can go to my distributed tracing system and paste it there and look into the data. What can I figure out from there? So I teach Grafana how to do it, so I don't need to do the copy paste, but you can use like any tool for that. You don't need to use like Grafana Tempo Loki for this. You can copy paste from any tool to another. The log contains the information, the distributed tracing backend contains the information, we are good. So you can see two things here. This one is kind of like the trace, consists of spans. This is the call tree that you like experience when that API was called. And there is also a timeline. From the timeline, I can tell interesting things. For example, these two calls, T-service is calling voter service, and T-service is calling tleaf service. They were not parallel. They were sequential. I can see that on the timeline. First, the first call, and then the other call. Let's see what else can we figure out from here, because this doesn't tell us why this is happening. It is just an additional information we have. So if I open the first span, which is saying to me that, hey, the T-service was called over HTTP and this was an HTTP GET to this endpoint, I can get some more details. Like this was like somehow a not found exception from somewhere. This was the full URL. I am getting server error and it was returning 500. Okay. What else can I figure out from here? There is one thing on this UI. See this red button or red icon? That means bad. That means there was an error. If I follow this, I can see that there was an error in tleaf service as well. And it seems that tleaf service says resource not found exception. It was a GET on this endpoint, client error 404. So it seems that T-service called tleaf service, tleaf returned 404, T-service mapped that to 500 and returned that to me on the UI. Why? I don't know. Why this is happening, why this is 4 on 4, I don't know. But let's look into deeper. So it seems that after this has happened and tleaf basically like received that HTTP request, it made a database connection. And the database is right here. It is using the MySQL driver and the Hickory CP. And after that connection was made, it seems that there was a database query. And you can see the whole query here. I'm sorry, this is Hibernate, the query is generated, I did not write it, but you can also like figure out what happened here. This was a select query with a bunch of fields from the tleaf table, where the name of the tleaf was something, and that something is English breakfast. So if you are very adventurous, you can just SSH to this host. That's mine, don't SSH to that. But in production, if you are very, very adventurous, please don't do this in production, except in dire cases. But you can SSH to the box, use this database, run this query, and you can check like what is the like the result set that was returned. I happen to have a result set here, and if I look into that, I can see that JDBC row count is 0, which means that this was an empty result set. The record is not in the database. Somebody, I don't know who, forgot about it. So let me try to fix it, and let's see if it will be like fixed on the UI and on the metrics. But before I would check it, we just saw how to jump from logs to traces. Nothing prevents us to jump back, because here the trace, we have the trace ID. We can go to our logging ingestion system and write a query that contains a trace ID. And I teach Tempo how to do that, and I can just like jump into the related logs, and I can see all of the log messages or all of the log statements for this one particular trace, for this one particular transaction throughout all of the applications. So you can see that this was T-service, this is voter service, that is tleaf service, all of my apps are here, and all of the interconnected logs are here. I can get like additional information from this as well. But another thing I wanted to show you, if it is fixed or not. It's fixed, we are good. So let's see if we can see this on the dashboard as well. Like, is it like really fixed for everyone, or it is just me who like this was fixed? And in order to do that, I want to show you the next concept, how to jump between traces and metrics. And you can basically do this by just checking all of these tags or attributes that you have on the span, and basically use these attributes to craft a query in your metric system. This does an assumption though. This assumes that the tags are the same. And I'm using the thing called Observation API here. The whole portfolio is instrumented with it, and that will ensure that. But what I can do now is I teach Tempo how to do this, and I can just ask to craft a query where the application is tservice, exception not found, method get, whatever, all of those things that are low cardinality. And now you can see that our error rate went back to 0. Or error rate, all of the similar spans went back to 0. And this happened to be an error span, so our error rate went back to 0. But I do have a real error rate on the dashboard. If I can go there. Yes, right here. So the last thing I want to demo with this application is how to jump from metrics to tracing. And this is kind of a hard problem to tackle because during disaggregation, you are losing data. Let's say that you had 1 million events. You aggregated them into one single number, an error rate equals 0.5. How can you jump back from that one single number, 0.5, to one of these 1 million events? It's impossible, right? Not really. What you can do, there is a concept called exemplars. And the exemplars are kind of like metadata that you can attach to your metric values. So whenever you are doing a recording, you can sample your distributed tracing library, and you can ask for the span ID and the trace ID. And you can wrap them together into this concept called exemplars, which is just metadata. And you can attach that to your metrics values. And during aggregation, you can basically look into this. So as you can see here, there are some data points that are not connected. And let me stop refreshing this. So there are data points which are not connected here. And those connect, or those contains the trace ID, the span ID, the value, and a bunch of other things. So what I can do, I can just grab the trace ID, go to my distributed tracing backend, and query it. And that's it. That's how I can jump between metrics and traces. Also, nothing prevents you to complete this circle and jump between logs and metrics. But in order to do that, you will need a trace ID. So you need to stop at distributed tracing, and that way you can jump between any of these signals. So let's talk about the Observation API, which is kind of a new thing in Micrometer. We released it 1.5 years ago, a little bit more. It will be 2 years old in November. But what the Observation API is doing, it is basically letting you to instrument your application without doing a lot of boilerplate. Because if you want to do it without it, what you should do is you go to your component and you add, for example, logging statements. Then you release it. Then you forget that, hey, I needed metrics. So you go back, modify the instrumentation again, add metrics, and release that as well. And then you realize, hey, I need distributed tracing. So you go back again, modify the instrumentation again, and so on. If you want to do other custom things, maybe you will end up with 3, 4, 5 types of instrumentation for one single component. So what the Observation API is doing, instead of this, it is saying hey, let's instrument your code base once and get multiple benefits out of it later. So what you can see here, I am not starting a timer for metrics and stopping it, or starting spans and stopping it. I am starting and stopping observations here. I am also signaling errors, and there are more I can attach, metadata, and do certain other things. I will show some of them. But what will happen if I do this in a component or an application? So if you are just on a public static void made a JVM application, and you don't do anything else, nothing. But why we are doing this then? So if you ask me, the heart of the Observation API is a component called Observation Registry. And the Observation Registry is basically a component that will be notified whenever somebody starts an observation or stops an observation, signals an error, and so on. So they can react to these events. They can say that, hey, I am implementing a metrics handler. We implemented that for you, you don't need to. So the metrics handler can basically start a timer if you start an observation and stop the timer when you start the observation, and it will report that data. A tracing handler can do the same with spans. Start a span, stop a span whenever you start and stop an observation. And you will get these out of the box if you are using Spring Boot. We will give you a metrics handler if Micrometer is on the class path, and we will give you a tracing handler out of the box if Micrometer tracing is on the class path. But what you can do here is just instrument your application or the component once, and without modifying that instrumentation, you can basically define what outputs you want to provide. Do you want metrics? Add the handler for it. Do you want tracing? Add the handler for it. Do you want some custom logging for some kind of events? Add the handler for it. Do you want to push data into an audit database table? You might guess it. Add the handler for that, and that's it. So you can, in Spring Boot, since it will do the auto configuration for you, it will not just add these default handlers for metrics and tracing. Whenever you create a bean from an observation handler, it will auto register it for you. And that's it. You can do whatever you want in your handler and produce whatever data you want. We also have shortcuts. You don't need to do this try, catch, finally dance all the time. Here I am saying, hey, create an observation, but do not start it. I am also adding some metadata, and then I call the observe method, and the parameter of that is a method reference. So this observe method, what it will do, start an observation, call your method, and stop the observation. And it will also do error handling. Try, catch, finally dance. You don't need to do that. You can do this as a shortcut. Also, there is an observe annotation. Does the same. And this is kind of like where we go into the more advanced things, where you want to instrument components or want to somehow interact with some instrumentation. So another very important component in the Observation API is called the observation context. And this is basically just a data holder that can hold all of the data that you as an instrumenter think it is important for everyone else that wants to look at that observation or get some data out of the instrumentation. For example, if you happen to instrument an HTTP client or server, this can contain the request and the response pairs. And the observation handler, as well as another component called observation convention, they will receive it. So when you want to produce the output of the observability data, you can get every single bit that you need, or the instrumenter thought that you will need, from the context. And also you can get you can also use this context not just to get data out of the instrumentation, but pass data between these handler methods, like on stop, on error, on start, whatever. You can use that as well to pass data between the handler methods. So let's look at some code and let's see what would this look like in a real-world application. So this is again from this tea house application I showed you. And what I did, I basically created an interface for my business logic. And I do have one default implementation that implements basically this, how to make a tea based on the name of the tea and the size of the tea. And I can observe this, or I can observe components in two ways. One, if that component will give me hook points, I can basically add some logic to that, but also I can wrap this tea service. So what I did, I created a observed tea service, which is also implementing the tea service, but this is not implementing any business logic. It is just having a delegate. It is decorating the tea service. And what it does, it is just creating an observation, not starting it. This is the name of the observation. It will also add some metadata about this, like what is the name of the tea and the size. And then it calls the delegate. And that's it. The component now is instrumented, which is pretty nice. But there are some problems. And the problem is that you saw my implementation that like values were hard-coded into the instrumentation. And the instrumentation was also kind of hard-coded. So how can you control that if you get a component where things are hard-coded? So there are two interesting components in the Observation API. One of them is called the Observation Predicate, and it is a by predicate. It's an open JDK or like a JDK interface, a functional interface, which basically gets a name, the name of the observation, and the whole context object. And based on these two parameters, your custom logic can decide about, do I want this observation or not? You can decide about to throw it away or keep it. So with the observation predicate, you can like decide if you want to ignore that observation or not. And also there is the observation filter, which is for modifying the context. The observation filter is a function over context and context. So its input will be a context and the output will be a context as well. And in that method, you can basically do the modification, but it has like a limitation. It will be called once right before the stop method. We will talk about like how to overcome this later and why this is a problem. But let's look into two examples for this. Yeah, where is it? Yeah. So I happen to have like a bean here, which is an observation predicate. Spring Boot will auto-configure this for you. And what it does, it is getting a name and the context. It checks if the name is equals to this magic string. This comes from the instrumentation for Spring MVC. I don't really need to do this because the other part of the of this is like if the context is instance of the server request observation context, which is coming from Spring MVC. So if I know that this is a context for server HTTP requests, then I can get the request out of the context, get the URI of the request and check if it starts with /actuator. Because here I want to say I want to drop every single observation that goes to any actuator endpoints. You can also say that, hey, I don't want like Spring security observations because it is like too chatty. You can basically write a predicate like this, check the name, check the type of the context, or like whatever you want to check, and drop it or keep it. The other thing I wanted to show you is the observation filter, which I am creating here. And what this filter does is, well, I need this filter because there is a bug in Tempo. So what I need to do when I am basically sending the data to Tempo, the spans that will be created from the observation, that data should have like certain metadata in it, in some cases. Otherwise, it will not work. So I need to do this modification, or hack actually. I am getting the context in this observation filter. I am checking if the context is a data source-based context, which means that this is for the instrumentation of JDBC. And then I add these extra metadata that Tempo needs because of the bug. If you are very curious what is this about, the code base contains the link to the bug as well, but it doesn't really matter. That's just basically a nice way or hack to modify the capabilities of like the observation filter. But let's also talk about the conventions that you basically saw in the code, because the instrumentation that you saw, it was like hard coding the name and also the metadata, like the tags. And you might want to like customize this convention, not necessarily with the observation filter, and also without rewriting the instrumentation. So everything is like hard-coded and a string in the instrumentation. How can we let the users, as the instrumenter, modify that thing? And also there is one very important thing here, is that you might want to control these changes. Whenever as a user you want to change the name of an observation or the tags, because that will mean an output change. It will mean that your metrics will change and maybe your spans will change. That's a breaking change. You might want to have some control over it and saying that, hey, I implemented both of those, or I have like one convention and another one how I name things, and I want to like configure the second one right now. So in order to do that, we came up with a component called observation convention. And the observation convention is basically a way to provide this data, the name of the observation and the metadata, the key values on it. And instrumentations can say that, hey, give me a observation convention, otherwise I will use my own. But if you provide me one, I will use that. So that you can basically have a default one, and you can have a custom one that is user provided. You can create these conventions in two ways. One, from scratch. It's a very simple interface. You don't need to implement a bunch of things. Second, you can basically extend the default one and just override the part that you need. Spring Framework, by the way, or like I would say like every instrumentation that we have in this Spring portfolio, they follow this concept. They will provide you a way to inject this convention and decide about or override these names. So let's look at some code again. And if I go to the Observability service, then somebody conveniently put some code here. And what you can see as a difference, I am also like doing the same thing, creating an observation, but not starting it. But instead of depending on these like hard-coded values, I am saying that these values should come from the convention. And I am saying, hey, there is a custom convention, which is injected from the constructor, so coming from the user. And if it is not there, I am like falling back to the default convention. Also, there is one more interesting thing here. I am also creating the context. I have a custom context called makeTcontext for two reasons. One, this way, I can get this information in a type-safe way. I have getters now. I know the get t name will give me the name of the t. And I don't need to guess what is this, the magic string key in a hash map. And the other thing is that because if I do this and have my own like convention, then when I implement my default make t convention, which will decide about the names, or the user will implement their own custom one, I can use this context. So what you can see here, this is like an implementation of the make t convention, the default one, the name is here, and all of the the key values are here. And what is happening here, they are coming from the context with a getter, which is like we are usually like write code in Java in a type-safe way. We don't really like to put like everything in the hash map and getting it out by strings. So this is good, and you can do like a bunch of things with it, and you can basically like customize your observations. But there is also a problem with that you might hit if you start like instrumenting components. And the problem is that keeping documentation in sync with the implementation is difficult and very error prone. So we introduced a new project like almost 2 years ago when we released the Micrometer Observation API. We also introduced Micrometer Docs generator. And this is a separate project in a separate repo. And what it does, it gives you a component called observation documentation. And you can use this observation documentation for basically two things. One, it can contain enums that will define these key values and the observation name so that you don't need to depend on those strings. You can depend on the enums, which is like another like more type-safe way to do this. And the other one is, this is like kind of like scannable by abstract syntax tree scanners. So you can scan these documentation objects and generate documentation out of them. And of course, this can be integrated with the observation convention. And that's what we are going to do. So if I, again, look into this Observability service, then somebody conveniently put here another piece of code. And the difference here, what you can see is I am here creating the observation through the observation interface. And now I am creating it from the documentation. Everything else is the same. So let's look into that. What is this and what this is doing? So there is one more thing I need to do. Since the documentation will now contain what is the, come on IntelliJ. Yeah. So it will contain information about what is the default convention, and also it will contain an enum about all the metadata that I want to attach. It is hard-coded here in the documentation, but everywhere else where you want to use some instrumentation, you would depend on the enums, not on the strings. So let's do that. If I go back to the convention without like doing like strings here, I can basically just depend on the enums and say I don't want like to hard code t.name here. I want to use the t name. And other conventions can use this as well. And if I have this, and if I run the right Gradle task or the right Maven goal, then this can create me some documentation if Gradle will be able to finish its job. Yes, okay. So if I go back here and check the docs folder, then hopefully some Jeopardy music. Okay. I get documentation. I see now what is the default convention, what is the interface, so I know what to override or re-implement if I need to. And also I have like a list of metrics that this instrumentation will create. What is their name? What are the tags that are available? What is required and will be always there or not? And the same for the spans. So I have a make t span here, which can contain a t name and a t size. So this is pretty nice. If you do this, your instrumentation will be very, very flexible. And if you want real-world examples for this, Spring is doing it. So if you look into the Spring MVC instrumentation, it is doing that. Webflux as well. REST template, REST client, web client, they are also doing this. And basically everything in the Spring portfolio, what is instrumented, have this built in. So I have two topics. Lastly, what is kind of new and what is kind of next in Micrometer and the Spring portfolio that is observability related. So the first thing we released improved exemplar support. And what this means that previously in this change in Prometheus, in the Prometheus server, it only supported exemplars for just a certain very, very narrow set of time series. We talked to the Prometheus people, I created a pull request, they merged it in and released, so now you can get exemplars for everything. And Micrometer added support to that very, very quickly after the Prometheus release. We also added a new component called Meter Provider. And the Meter Provider is very, very useful if you want to create metrics with dynamic tags. If you are doing it, please look into this. It is not just like a syntactic sugar and much nicer, but in some cases it can give you performance improvements. We upgraded Micrometer to Prometheus Java Client 1.x, and that is the new Prometheus client. After 9 years, Prometheus released 1.0 after 0.x. So if you are depending on the Prometheus client in your application, you might be broken because of this change. But we also kept the old client in Micrometer. So if you don't want to migrate, but you want to use the old client still, you can do this by just renaming your artifact ID that you are using, your dependency. And that is basically it. But I would encourage you to migrate. We have a new doc site. If you go to micrometer.io, it is nicer. It has new search capabilities and so on. We made a lot of observability-related improvements in the Spring portfolio around context propagation and log correlation. There were a bunch of changes to make this better and faster. And also we added a lot of auto instrumentations throughout the past 1 year. So now you can get, for example, instrumentation for the schedule, the async annotations, also for JMS and so on. There are many. REST client was also instrumented. And we also did some performance improvements. This is there was recently a very, very interesting one in Reactor. So please, if you can, upgrade Spring Boot, which will upgrade Micrometer for you, and also like Reactor, so that you will get all of these improvements. And there is one more thing in Spring Boot 3.3. There was a new actuator endpoint that was added. It is called the SBOM endpoint. And it stands for Software Bill of Materials. And what it does, it will give you a list of all of your dependencies and their versions that your application is depending on runtime. So what you can do, you can basically ask your application, hey, am I using the wrong version of Log4j2 that is vulnerable for Log4Shell? And you can just see it if you are using the wrong version or you are using the version that is also already fixed. The last slide, let's talk about what is next. And this is next in the terms, these are like already released in like the latest milestones. So next week, basically. Or like, sorry, last week, basically. So we added exponential histogram support in Micrometer only for OTLP. That is basically like a new histogram format. That's it. We also added some extra validation logic for testing purposes. If you are using this test observation registry, which is for testing your instrumentation, now it has like additional like validation capabilities. And if you are doing something wrong with the API, you are misusing it, it will throw an exception at you. But only in the test, for tests, not in production. So for example, if you like stop an observation without starting it, it will tell you. In Boot, we added 3 new components. The first one is process info contributor, which will give you like process related information. For example, who is the owner of the process? What's the process ID? What is the, I guess like the CPU count that the process can see, mostly through C groups. And what is the memory as well that the process can utilize. And we also added like SSL related, an info contributor and a health indicator. And what they do, if you are using the SSL bundles feature, it is basically giving you information about all of the certificates. Doesn't matter if it is a client or a server certificate that you have. It will tell you what is the issuer, what is the subject, what are the validity dates, is it like expired, not yet valid, and it can also tell you if the certificate will be expired in a time span that you define. So you define the threshold and you can tell Spring Boot, hey, let me know if one of my certificates will expire in the next 30 days. And yeah, it can give you some headroom in order to rotate those certificates. So this is a really nice feature if you ask me. And if you attended any of these Spring AI talks, I believe it was mentioned that we added instrumentation to Spring AI. It is in the latest release that was released like the end of last week. And now you can get like some instrumentation or some data about what your like Spring AI logic is doing, which is pretty nice in order to figure out like what happened or what is wrong with your application if you are using Spring AI. So I believe that's it. Thank you very much. You can find my social handle there, my blog. There is the URL for the GitHub repo. And if you want to ask questions from the Micrometer team, there is slack.micrometer.io. You can reach us there. But if you have any questions right now, please let me know.
Yeah, amazing. Great job. Thank you.
I have stickers. I have Micrometer and Spring stickers if you want to.
So now we all know how to read the tea leaves. That was a great, very comprehensive talk. Any questions in the room here? I'll pass the microphone if there's any questions. As you think, I'll just remind you and the people on the live stream. First of all, thank you everybody for coming. Thanks to those online for joining us. I hope that you got a lot of useful information out of today and the last couple of days. All of the videos will be posted on YouTube under 2 different channels, at SpringSource Dev and the at Tanzu channel. So you'll be able to watch them all again if you want, or send them to your friends. So yeah, last chance for any questions on any of the stuff that Jonathan shared. So great job. Packed with information. Truly, truly packed talk. I really enjoyed it. So that's it, everybody. Thanks again.
Thank you.